Alright everyone, this is again take two. First video was 20 minutes long. It's too long. This video is for April 1st, 2020, Wednesday. Happy April Fool's Day. No pranks today though, just math. Sorry to disappoint. Alright, so today we are going to be graphing polynomials. Okay, and so specifically here, I already have some of the notes written up for us. So we're going to be looking, well, yesterday we looked at end behavior, right? And we already figured out how to identify the end behavior for a function. Today we're going to include finding the zeros and the middle behavior to then create the graph of a sketch, I should say a sketch of a graph of a polynomial. And you'll see what I mean by sketch here in just a second. Okay, so here's our question. We are asked to sketch f of x equals negative x times x minus 2 times x plus 2. Okay, so first thing we'll do is determine the end behavior. All right, so why don't you guys go ahead, pause the video, and see if you can figure out what the end behavior is. Okay, so end behavior, right, requires us to determine the degree. And again, you can multiply this whole thing out if you wanted to, but really we just need to multiply the highest powered term in each polynomial that we're multiplying here. So in other words, you're going to end up with x times x, which is x to the third. It was a negative 1 times a positive 1 times a negative, or positive 1 again, because negative 1. And it'll have some other junk too. We don't really care about that. That's going to be our lead coefficient right there. Lead term, I should say. And so the degree will be 3. Okay. And then the a value there is that negative 1. Okay. And so that gives us our important information there. Which means the end behavior, since it's odd, we're going to have one end go up, one end go down. And since it's a negative 1, it will be the right end that goes down, and the left end, as we go extremely to the left, will go up. Okay. We'll also find the zeros. How do you find the zeros for a function? Well, you just set the function equal to 0. So we'll set f of x equal to 0, so we'll have 0 equals negative x times x minus 2 times x plus 2, like that. And so what do we get? We get x is 0. We'll get negative x is 0. We'll get x minus 2 is 0. We'll get x plus 2 is 0. So if I solve, here we get x is 0, we get x equals 2, and we get x equals negative 2. All right, now I'll go to graph this. And I'm going to plot in, let's see, 1, 2, 3, and negative 1, negative 2, negative 3, like so. Okay, on the y-axis, I'm not going to put any numbers, all right, because, well, you'll see here, we're not going to be so concerned about getting exact values. We just want to kind of get an idea of what this graph is going to look like. So I'll put down my zeros at 0, at 2, and at negative 2, there are my 3 zeros. And now I need to figure out what happens in between those zeros. Oh, actually, first, let me do the end behavior. So this first part of the end behavior here says as we go really far to the right, we're supposed to go to negative infinity, which means you're going to go down. So here is my furthest right point, and so we're going to go down from there. Okay. Likewise, the other end behavior here, as we go far to the left, this indicates we have to go up, right? So here's my leftmost point, and we need to go up from there. So up, like so. Okay? Now, that gives us our end behavior. Now we're going to worry about what happens in between, right? You might be like, Mr. Wick, can we just like make it go up and down and up like that? And yeah, that could be right, but it doesn't have to be right, okay? In fact, the graph could do something like this. Okay, that could work, all right? So you have to be a little more careful, or it could do something like this. Okay, or it could do something like this. Okay, so you want to be a little bit careful there, and those aren't pointed, those are smooth little transitions there. So you need to figure out exactly what's happening between the zeros. How can we figure that out? Well, an easy way to do it, and one that will always work with calculations and stuff like that, is to list out your zeros here in order, and then pick numbers between your zeros. So for example, negative 1 is between negative 2 and 0, and 1 is between 0 and 2. And we're just going to plug those into our function. And so when I plug negative 1 into my function here, it'll be negative 1. Let's see, I'm going to get that function. Zoom out some. Okay, negative 1 times negative 1 minus 2 times negative 1 plus 2. Okay, and if we do that math, that becomes a 1, that becomes -3, and that becomes 1, so it becomes -3 there. Okay, and if I plug in f(1) into my function, it's -1 times 1 minus 2 times 1 plus 2, which becomes a -1 and a -1 and a 3. And we get +3 there. And then we're going to just roughly sketch these. So I have the point 1, 3, and I have the point -1, -3. So 1, 3 would put us like right here, and -1, -3 put us like maybe right there. And then we can connect those dots and create our graph. Here's why I say this is a sketch, though. If I take this function we talked about, and I go to graph it, okay, so here you can see I've got my function typed in. There's -x times x minus 2 times x plus 2. Go to the graph. Second trace, right, we'll go to, let's find the maximum point. So I'll go to the left of a maximum, hit enter, go to the right of the maximum, hit enter, and go to the actual highest point and hit enter. And you can see the maximum does not actually occur at 1, 3. If I go to the minimum, which will go to find this point, lower point right here, go to the left, go to the right, guess it, and you can see again, it's not at -1, -3. What's happening here? Well, what we're doing is just trying to get an idea about what the shape of the graph is. We're not being as precise as we have been with some of our other functions, okay? So what that results in is, you know, inaccurate maximums and minimums, all right? So that's why we don't even bother really putting any labels here on our axes because, well, they're not necessarily the highest points and stuff like that. We just want to know what the graph kind of looks like, okay? Another way you can do this, if you don't want to have to like plug in points like we did right here, is you can instead look at the multiplicity of the zeros. So for example here, this 0, right, it has a multiplicity or a power of 1. This 0 right here, it has a multiplicity of 1. And this 0 right here also has a multiplicity or power of 1. So since they are all odd, since each multiplicity is odd, that means through each one of the zeros, the graph will go through the 0, right? So here with x minus 2, right, its multiplicity is 1. And so going through that 0 that it creates, right, our graph goes through the 0 here. Okay, at this 0 right here, right, that gives us the 0 of 0, right, we go through the graph, through the x-axis like that. And then, of course, same thing for the other one, okay? Other things real quick I just want to mention, this is a relative maximum. This is also called a relative minimum, sometimes also referred to as a local instead of relative, local maximum or local minimum. Okay, relative or local because they are not the highest points, right? But they are high points for their little neighborhood of points right in here or right in here. All right, let's try another example here before I run out of time completely. Okay, I'm going to breeze through this one and then the next one as well. All right, so here, same thing, we're going to sketch. All right, so the degree here is 3, lead coefficient is 1. That means our end behavior is what? Pause the video. Yes, it should be infinity and negative infinity here. All right, so I'll go and let's go ahead and find our zeros. So we'll set our function here. Okay, we don't have it factored yet, so we need to factor. Okay, so we'll factor out an x squared. Set each factor equal to 0 here. And so we get x equals 0, right? This is square rooting to get that. And of course, it's plus or minus 0, but there's no positive or negative 0. It's just 0. And we get x equals 2 there. Okay, we'll go and graph this thing. Okay, there's my 0 at 0. There's my 0 at 2. Okay, and then we'll figure out what happens in between. Well, sorry, end behavior again. Sorry. So again, for this end behavior, further right we go, we should go up. So we're going to go right to the rightmost point there and go up from there. All right. Then this end behavior tells us that as the farthest left we go, we should go down, right? So the farthest left point is this point right here. So we're going to go down from there. Okay. And then how do we finish the rest? Well, let's look back at our zeros here. So x minus 2 over here, that factor has a power of 1, which means we should go through the graph, okay, at 2. However, the 0 that we get from x squared, right, it has a power of 2. And so we should be bumping off of this. And even power means you kind of come down, you come up, and then you bump off of it and go back down. And again, if you want to check this, you can graph this function here in your graphing calculator too. Okay? Again, we have a relative minimum, and we have a relative maximum. Okay? One more here. And again, you can do the middle behavior if you really want to. Sorry, back to this previous one. You could, pick like 1, for example, which is between the two zeros, and plug it in and see what the y values are. But again, you can just use your multiplicity to help you there. All right, let's look at this one. So the degree here, well, there are 1, 2, 3, 4 x's for us to multiply together. So that's going to be x to the 4th. And that's going to be a negative 1 times a 1 times a 1 times a 1 times a 1. So that's going to be negative 1 x to the 4th, and plus some other junk we don't care about. So the degree is 4. So it's even degree, and the a lead coefficient is negative 1. So what's our end behavior? Hopefully you said negative infinity, and negative infinity there. Okay, the zeros are easy enough. I'll just go ahead and write these out. Okay, it's going to be x equals 4, x equals 1, x equals negative 1, and x equals negative 2. Again, that's setting each one of these equal to 0, right? Because we're setting the whole function equal to 0, and then using zero product property there. Okay, sketch the graph. 1, 2, 3, 4. 1, 2, 3, 4. Okay, and we plot these points. So 1, 4, negative 1, and negative 2. Okay, each one of these zeros, end behavior, I always forget to do that first. So from the end behavior, okay, as we go far to the right, we're going to go down. So farthest right point, go down. From this one, as we go far to the left, again, x approaching negative infinity, that's the farthest left, we're going to go down. So here's our leftmost point. Go down from there too. Okay, each one of these zeros, okay, has multiplicity of 1, odd multiplicity, so that means we go through. So we're going to go up, through, 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 like that. Ooh, well, let's try that again. Like that. Okay, much better. So there's our graph. Here in this case, we have 1, 2 relative or local maximums, We have 1 relative minimum. Okay, now, the other thing I'll point out here is that one of these two is also going to be an absolute or global maximum. Okay, it's going to be the highest point. Okay, there is no absolute minimum because our graph goes down at both endpoints there. Okay, this is important vocabulary for you guys to understand, especially if you're planning on going to calculus. All right, so that concludes the lesson. Please check it out on Schoology, your assignment and stuff like that. If you have any questions, I now have given you the option, the capability to comment on my postings on the update page. So please comment on those if you have questions about the homework. And yeah, email message me if you have any other problems.